Okay, so this was the structure declaration that we had before with the 4 fields. Now what we're going to add there is going to be this pointer parameter. And you'll notice here that the type that we gave it was student star. So meaning pointer to a student structure object. And it'll be pointing at either another object or at null PTR if it's the if it happens to be the very last node within the linked list. And then we'll start here with kind of the basics in terms of just building a small list here with a few nodes. And we'll see how we can connect them together through this pointer called next. So this pointer next here is kind of the key to making everything work. So it is important that every single student object now has this extra pointer field, because that's going to be the entire basis as far as connecting them together to form this list. And then after we do it, we'll eventually look at the memory diagram, meaning the a possible memory diagram that corresponds to the linked list that we're building, because it is important to think about the differences in terms of memory with a linked list setup versus an array setup, because it's certainly a different situation in memory with the two. And so now the idea is that in terms of the structure itself, we only have one pointer there with what we call a single linked list. But there's still going to be other pointers that we have to use to ultimately do things like build up our list and process our nodes and so on and so forth. But the difference is, whereas, for example, this next pointer is in the structure declaration itself, and the reason for that is because every single node needs to have this. The other pointers that we declare are not going to be within the structure declaration, because we have to make those kinds of distinctions, right? Is this a pointer that there's only one version of it, or, for example, one copy of it? Or is this a pointer that we're talking about that has to be in every single node? So the answer for next is that it does need to be in every node. But with the other pointers that we're going to start declaring here in main, they are not going to be within every node. And so one pointer that we're certainly going to always have is a pointer that is used to maintain the head or the beginning of the list, because this is our entry point, right? Everything with a single linked list in general is going to be starting with the head. And we'll initialize it to null PTR here in the beginning. So in this case, we just said student star, which is also the type of next over here. But student star, name of the pointer is head, and then it's initialized. It's initialized to null PTR. So right now we're saying the list is empty since we haven't actually created anything. So we have it set to null PTR, but then that's going to change as we start building this list from the ground up. And another pointer that we'll have here is a pointer named new nodes. So the idea is that every time that we create a brand new node, we're going to do that with the help of this pointer called new node. Whereas head is something that we'll always keep at the head or the beginning of the list. And so what we can do now as a starting point is we can think about things like dynamic memory allocation and um, creating each node and then connecting them together through these next pointers. And again, we're using the arrow operator here because especially as with linked list, some cases we might even use the arrow operator multiple times in the same statement. So it's a little, it's a little bit more convenient than having to use the longer expression where you have to use both the star and the dot along with the parentheses. Because that was one thing that we mentioned also last time, was that a statement like this was equivalent to the whole parentheses star new node and then after the parentheses dot name. So we're just using the arrow operator here. And that's our first node. And again, we did this dynamically. But we created this new node, and then we went ahead and set, in this case, the 4 fields, the name to James, and then the ID number, letter grade, and test score. And now, again, we're doing this as a hard-coded example, but eventually we'll want to also think about things like, in general, being able to build a list, for example, using user input. But we built this list here, and this is also the first node, or this is about to become the first node within our list. And so what we're doing is that every time we create a new node, we're using this pointer here, meaning this pointer new node. And then we're doing that with dynamic memory allocation, right? So dynamically create a new student object and then have new node point at that and then set the fields here. And we're also going to want to make sure that we set the head pointer as well. So we want, now that we have our first node here, we want to have the head pointer point at that node instead of having it still point at null PTR. So we're going to go ahead and do that as well. So for now, at least, they both, right, both of the 2 pointers point there. But we're going to go ahead and now we're going to create our second node. So we're going to use these 2 pointers together. Because now what we can do is we can go ahead and create our second node, still using that pointer new node. And then after we do that, we'll talk about how we can connect it to the first node. And so we're going to go ahead and do a similar block to create the second node here. But now we also want to think about, now we want to connect these two, because at the moment what we've done is we've created 2 different nodes dynamically using DMA. But at the moment they're not actually connected to each other, right? So at the moment they're just 2 separate nodes in memory that have really no correspondence to each other. But now we want to actually form them into a list. And so that's where this extra field called next is going to come into play. Because one thing that we can notice here is that when we created the first node through dynamic memory allocation, we went ahead and set right these 4 fields, but we haven't actually set the next pointer for the first node. And that's what we're about to do right now, because now we want to take this James node, right, the first node, and connect it to this node that's called Steve. So in this case, James is going to be the first node and then in our list, and then this node Steve is going to be the second node. And the way that they're going to be connected, because they're not an array, so the only way that they're going to be connected to each other is through the next pointer. So that's the key to making this whole thing work. But see, now we've reached the point where what we have really is head is pointing at the first node, right? This node that we call James. And then in this case, new node is now pointing at this node called Steve. So if we want to kind of visually think about where we're at as we're going along here, we can look at a diagram here, and then we'll see how to connect these 2 nodes together. Because eventually we're going to add a few more nodes, but we're going to be following the same general process to connect them one by one to form a full list in the end with all the nodes fully connected.